Hello, everyone. Welcome to the webinar. We are right on 7 on the dot. So I'm Jussi. I do all kinds of janitorial duties here at Hamina, and I am sitting in Joel's basement, pretty much you could say. So this is a room in our office that's decorated by the man, the myth, the legend. So over to you, Mr. Crane.
Yeah, and to be clear, the whole AP wall was Jerry's idea. I just added some LEDs in front of our AP wall. So thank you very much to Jerry. Yeah, I'm Joel from Hamina. I put APs on walls. Let's go to Jerry.
I'm such a trendsetter. Yeah, Jerry, I'm the US based side of our technical operations here at Hamina. Julio, how about you?
Yeah, well, thank you, Jerry. Hey, I'm Julio Petrovitch, product manager at NetAlly, and today I'm just a guest on Hamina's webcast.
I might as well follow. Hey, Dan Klimke, Director of Product Marketing at NetAlly. Glad to be with the team today. How about over to Kjetil?
Yeah, I'm Kjetil. I'm also a guest here with from a company called Blue Tree.
Thank you, everybody, for joining. And right at the second, Keith Parsons has joined.
The man, the myth, the legend.
Barely a man.
But very much a myth and a legend. The man, the myth, and or a legend. How are you, Keith? One sentence introductions is where we were at.
Keith Parsons, glad to be here. I like using spectrum analyzers when I need to.
Excellent, excellent. Welcome to the show, Keith. And we thought we would start by Joel giving a little bit of an overview to Wi-Fi, and why not other spectrums as well. So let's get a 5-minute overview on spectrum presented by the man, the myth, and or legend, Mr. Crane.
Well, there can only be one man, myth, or legend on one webinar at a time, but I do appreciate that. Yeah, so I don't know if I'll take a full 5 minutes. I mean, I can if you really want me to, but this is a little tool that I made. It's at spectrum.potatofy.com. You can go to it right now and check it out if you'd like to. And it's just a little interactive spectrum chart. And one thing that I really enjoy doing is zooming way out to look at the full spectrum that we have available. I'm going to go turn Bluetooth off just to get it out of the way. And it's actually kind of fun to look like, at least in the United States, there is a ton of spectrum available for us to use for various unlicensed activities. There's a little bit down here in the 900 megahertz band. This is where 802.11ah or Halo lives. In Europe, it's down here in the EU 863 band. So we have 5 channels down here that we get to use for sub 1 gigahertz Wi-Fi. And then one thing that really bothers me is that Japan uses these like 500 kilohertz offset channels. That just bugs me for some reason. Like, it just really bothers me a whole lot. Although one thing that's really comforting is if you zoom in really close to look at the subcarriers, at least the subcarriers line up. So there's that. So, it's not a total loss in my mind. But if we go back and we look at the 2.4 and then all the way up to the 5 and the 6 gigahertz band, one thing that's really striking to me is how these bands are they're right next to each other. Like, we tend to think of 2.4 is way down there, and it kind of is. 5 and 6 gigahertz are really almost contiguous spectrum. In fact, if you turn on Uni 4, it gets within, just a few megahertz of being contiguous spectrum between the two bands here. Although one bummer is I'm showing you basically the whole world here, or like sort of everything that's possibly available anywhere in the world. But if we take out the US and we show just the EU and Australia and Japan, you can see we lose quite a bit of spectrum, specifically thinking about the 6 gigahertz band. Let's just go turn the US back on. You see the US has quite a bit of spectrum, whereas everywhere else, not so much. And wasn't there some news about this week? I haven't really kept up on things. Has anybody been keeping up on what's going on with the spectrum availability in Europe? Any comments on that?
Man, it's looking worse and worse for added 6 gigahertz for Europe. So Europe has less than half, right? And it's not looking great that we will get any more. So the spectrum policy groups, recommendation has come out, and I'll just maybe I'll share my screen quickly on that if you don't mind, Joel.
Yep, all done here.
So here's Wi-Fi Alliance's opinion on that, but essentially the Radio Spectrum Policy Group has, in its infinite wisdom, they're starting to recommend that Wi-Fi doesn't really need that much frequency. You know, who uses Wi-Fi anyway? It's a fad. It'll pass. Give it a month or two, and Wi-Fi will be gone. So it's looking like we will not be getting a lot of the upper band of Wi-Fi for our usage, which isn't that great. So if you're into Wi-Fi, maybe I will just put a link on the chat. Go out there and maybe retweet this post and comment on your dissatisfaction and you know, or repost it on LinkedIn and say it would be nice to get, you know, more frequency for Wi-Fi. It's too bad that you know, that may not happen, but you know, these kind of things happen, and granted, it needs to be a balance between kind of the telecom operators and Wi-Fi and stuff like that. But given Wi-Fi's like massive success, it would be nice to have, because US already gets that upper 6 gig band, right? As Joel was showing in the spectrum graph.
Hey, so what was the logic behind declining that? It was said like, I don't know, they really don't think anyone needs it, or they need it for something else?
I don't think there was a lot of logic behind it. I think it is only a recommendation at the moment to the European Commission, so it's not like a final statement. It's a strong recommendation, so I hope, you know, that's why I agree with you, C. If you can repost it, express your the more voices we can get, the better, I would say. I think that the problem that Europe's always had is when you go to a lot of the meetings with the regulators are massively, if you look at who goes, it is mainly the telco providers and the cellular world. The Wi-Fi world, I've been saying it for a long time, is very, very underrepresented. So I think in the US there's a little bit more representation, and I think that comes from a lot of the vendors being US based.
Yeah.
And I think in Europe it doesn't get that much representation, sadly. And I think that is the logic. It's just underrepresentation at the important meetings.
Jer Bear.
So I was actually just hanging out with Mr. Parsons, Keith, at WLPC Mexico, just a week or two ago. And one of the things I learned there with some of the folks in the Latin America area is Brazil. I don't know if we got anybody on in Brazil in chat, but yeah, apparently they had or currently have 1200 megahertz and 6 gigahertz, but now it sounds like there was a decision to actually break that up and actually remove and kind of retrace that. Of now they're going to take the upper 6 gigahertz and you know, give that to I think the cellular side of things. So yeah, so we're actually even seeing some of that happening in reverse too, of not only not expanding, you know, more areas to use the full 1200 megahertz, but even some places that had 1200 megahertz are now breaking that up and just keeping the lower 500 megahertz for Wi-Fi, and then giving that upper to other technology.
Yeah, it's definitely not a static thing. It's what it looks like, and that actually leads us to kind of maybe that's a good segue. Unless Joel, did you have something more to show? Can you show the channel widths a little bit, like on 5 and 6, and kind of what the impact is in terms of channel widths?
Yeah, I can do that. Let's see. Let me get back to it really quick here. Okay, so if we go look at I'm just going to go up to the 6 gigahertz band. This is, of course, accounting for, you know, the entire spectrum, everything that's available in the United States. These are all the 20 megahertz wide channels that are available, and I sort of think of these as the building blocks. Like each one of these is sort of a building block that you can use to build a wider channel. Of course, the further up you go in channel width, the more bandwidth you get, literally, and the more speed you can get out of it, for example. So what you can do is you can start, you know, going up to maybe like 40 megahertz wide channels. So I'll turn the 20s off. So now you see these are all 40 megahertz wide channels. Let's step up again and go up to the 80 megahertz wide channels. So now we're looking at the 80 megahertz wide channels. And then finally the 160s. And then at the very, very tip top is the 320 megahertz channels, which one thing I didn't realize until I was building out this chart is that they are sort of in this stair-stepped pattern like this. I'm used to sort of the good old days of like 802.11 AC and things like that, where, you know, every channel had its own little space, you know, like for example, the 80 megahertz channels down in the 5 gigahertz band. But with these 320s, you get these really funky stair-stepping sort of things that happen. So, yeah, go ahead. You see comment?
Yeah, essentially, like it is double the data rate. If you double the channel width, it's double the data rate, and like typically even double the throughput, assuming, you know, certain things. But if you set it to 80 megahertz, for example, if we look at 80 megahertz, which would give like really good data rates, and then we compare, like if you compare between America like settings and EU, this is where we can see like how much of these 80 megahertz channels we lose as you take out US. It's less than half, so you only get like 5 or 6 80 megahertz channels in the EU, which is barely enough for channel reuse and is not enough for channel reuse in crowded environments, right? So even with 6 gigahertz, we kind of fall back to narrow channels in EU because of the lack of, and thus, you know, lower throughputs, lower data rates, right?
Yeah, I think you're falling back to 40 megahertz channels in most environments. Maybe some really dense stuff, you're going all the way down to 20s, but I have a feeling it's going to be mostly 40s off the top of my head.
Exactly. Whereas 5 gigahertz used to be like 20s, maybe 40s. You know, the goal of 6 gigahertz was to be 80s, maybe back to 40s, but that doesn't, the 80 stuff at least doesn't really compute in Europe with the current settings. But c'est la vie, enough of the whining. Thank you, Joel, for the demo, and I put in a link to the Spectrum. What's next for the Spectrum tool?
I think I'm going to add ultra wideband and DECT. I want to see where I literally have no idea where DECT lives, and this tool kind of has this fun thing where I can just plot it and let the computer tell me where it is, and I want to know where DECT is, and I want to know, I want to visualize where ultra wideband is as well. So yeah, maybe that's next. We'll see.
That's so cool.
Am I missing it, or is there nothing that marks PSC channels in here?
That is another thing actually I need to add. I think I'll just do a different color or something like that so you can see where the PSCs are. So that one that's really low hanging fruit. I need to do that soon.
So PSCs, Joel, a quick explanation for those that.
Sure. Yeah, happy to talk about. I can talk about this stuff all day long, but I'm worried it's going to become the Joel webinar. So when we just had the 5 gigahertz band. If you've got a Wi-Fi adapter that's looking for networks, it needs to tune to a channel and listen to that channel to hear any beacons or probe responses. And it has to hang out on that channel for like 100 milliseconds, maybe 120 milliseconds, something like that. When you only have like 25, 26 channels to chew through, it doesn't take very long for a client to scan everything and see what's out there and then make a decision about which access point to connect to. The problem is that when you add the 6 gigahertz band, especially in the United States on it, now we're talking, now we're looking at like maybe a Wi-Fi adapter needs like 10 seconds, 8-10 seconds to chew through all the 2.45 and 6 gigahertz channels. So PSCs are these primary scan channels. Maybe you guys help me out a little bit. I don't remember my PSCs off the top of my head. I've been relying on tools too much. Isn't 9 a PSC? 21? Am I right? I'm looking at Peter. I'm looking at Jerry. I'm looking at Keith. Yeah.
5.
Okay, thank you.
It's 5. It starts at.
No, it starts at 5.
4th. And then every 4th.
Okay. Well, I just need to put it in my tool. That's what I need to do.
Well, actually, some tools mistakenly show 1 as the PSC, but yeah.
Yeah, no,
gotcha.
If you take the like the 80s, it's like the second in every 4th.
It's the second in every 4th
so
on an 80.
It starts at 5, and then it's every second.
Okay, so 5, 21, 37, 53, so on. Nice. So one thing that helps with this though is there's R&R, reduced neighbor reports. Am I thinking of the right thing? I'm looking again at Jerry to see if there's a nod or something like that. I don't feel really confident on this 6 gigahertz stuff. But if I remember correctly, R&R gets included in a beacon and it will say like, hey, I'm a 5 gigahertz radio, but I have a 6 gigahertz radio co-located with me. Here's the channel it's on, so you can go and find it. That's really useful for us as a tools vendor too. That helps us out with discovery and things like that quite a bit.
The other cool thing about R&R is that some vendors are now putting neighboring 6 gig radios as well as not just a co-located one.
Killer.
So you can see they're basically doing the neighbor reports that they would send out in an 11K response, and they're putting all that information. So you don't just learn about your co-located 6 gig, you learn about your neighboring 6 gig radios, which is kind of
fantastic. Love it. It is also mega useful for us as tools vendors. I'm looking at Julio. I'm looking at Dan. If we need to figure out which BSSIDs are located in the same box for like mapping purposes and things like that, R&R is really, really handy. So very
kind of binding the different radios and MAC addresses into a single box gets so much easier with R&R. Go ahead, Julio. Sorry.
Oh yeah, that's a good idea. I think I'll keep it in mind. So.
Excellent. And speaking of spectrum, I was just gonna like, so there's a lot of things you can capture, like, and you know, with just a plain Wi-Fi adapter, and this kind of also maybe plays out to the spectrum side of things in general. So here's a stadium in Europe which pretty heavily utilizes all the 5 gigahertz channels, right? This stadium was refurbished before 6 gigahertz was available. And Keith, for example, and Ferney and the guys have surveyed a ton of these kind of stadiums too. You've done 6 gigahertz stadiums as well, but this one, as we can see, like wherever we have surveyed, it's kind of like, and the color of the bar says how crowded the channel is, or like what's the channel utilization. All of this data is just from the Wi-Fi adapter, and we can see that, yeah, actually on this, for example, on this stadium, there's no way to avoid channel interference, even if you use the narrowest possible channels, the 20 megahertz channels on 5 gig, and it's not even a very dense stadium, and still we can see that there is channel interference. Look at channel 36. There's 4 APs on channel 36 in this location where the roaming man is. There's 3 APs on channel 104. So even just like 20 megahertz channels on 5 gigahertz, as I move the roaming man, look at that. Like it's constant channel interference all the time, a little bit on this stadium. Luckily, though, it's a well-configured network, and it was empty when we surveyed this. Remember, Joel?
I think if there was bodies there, you get different data. But then again, if there's bodies there, you couldn't do that data.
Exactly, that's well said.
Climbing over everyone.
Yep, especially if it was under seat. This was like behind in the walls, and then a lot of overhead, I believe, was this setup. They did not have under seat, but if it's AP is under seat, then it's massively different, like Keith said. Like the cell size shrinks, channel interference disappears, all of that kind of stuff. What do you think about 2.4 on this empty stadium, by the way? Any guesses?
It's off.
Hopefully, yeah.
That would be great, but it's not possible on this stadium. But yeah, it's pretty crowded, even though it's pretty well controlled, but still crowded.
I'm also amazed when I see the actually 1.6.11. I rarely see only those channels being used by vendors.
Yeah,
always one. Channel
Absolutely.
7 and 4
and I believe they had to keep minimum data rate to 11, and that is the reason like these guys are red, right? The minimum data rates are still so high because of IoT devices that had to be there. If you disabled the B rates and took it like minimum data rates to 24 or something, would be a different story, I believe.
But they still obviously have lots of APs turned off on 2.4.
Yes, well said, because it's like only a few per channel, right? So absolutely. The other thing that I found fascinating, can you see my screen?
Yep, we got it.
Yeah, we can see.
Excellent. So all I have is my iPhone, right? And a normal like Wi-Fi adapter equipped device such as the NetAlly G3 or the ASIUM Nomad or stuff like that for analysis. And even from those guys, even without the spectrum analyzer, whether you're using G2, G3, ASIUM Nomad, these kind of things, you actually get quite a lot out of it. And we're not even, Keith would say, you're not even extracting half of it, and you say there's a lot of data coming out. This is also true, but there's a lot of data you can extract from just the Wi-Fi adapters, right? So you get kind of the utilization of the network, you get the like number of associated clients, you get all the SSIDs, APs, their properties, things of that nature. And I was doing a test earlier this week, which I posted on LinkedIn. Did anybody see that one? I did one with a microwave oven. What's that?
The running for the train?
Not the running to the
that
train.
One. Yeah.
Yes, that exact one. Thank you, Kjetil, for guiding me to the train. It was the one where I fired up a microwave oven, and you could actually see the utilization, even using just a plain Wi-Fi adapter. You could see the utilization rise, right? Which to me was quite fascinating. That the Wi-Fi adapters and kind of we're basing this on the QBSS load, but it is impacted by not just Wi-Fi devices, how crowded it is in terms of Wi-Fi devices, but also how crowded it is in terms of like non-Wi-Fi interference.
Yeah, the way we like to think of it when, for example, using one of our tools is that one of the first things you will normally do, you'll go and take a look at utilization overall on the channels, both Wi-Fi and non-Wi-Fi. And then if you see that there's a big amount of non-Wi-Fi traffic in there and you're wondering, okay, what's going on here? What's generating all that traffic? Then that's when you move on to something a little more detailed or will give you more visibility, like a spectrum analyzer. But it's at least a great place to start, because maybe it's just a lot of Wi-Fi traffic. And
Yep. And of course, there's limitations to the Wi-Fi chips on how much they can see. But to Keith asked a good question on like, what is the delay on like if you fire up like if there's non-Wi-Fi interference, it's actually, to me, it was shown instantly even without a spectrum analyzer. Like the QBSS load seems to react absolutely instantly. That's probably vendor dependent too, but at least for what I've seen, it is instant or like less than a second. There might, like different vendors may average out different things, you know, in different ways. But yeah, it is pretty instant. Do you have Julio? So was this the driving reason, and Dan, for you guys to kind of come out with something that's you know, beefier, to come out with a spectrum analyzer? You've been in this game for a while already, haven't you? In the like network analysis, but also spectrum analysis game.
Dan, you're on mute.
Yes, I am. So yeah, it's been a while. I think the first, you know, I think everybody's pretty much familiar with NetAlly's heritage, but we really got our start back at Fluke back in the mid 1990s. And one of the companies we acquired was a company called, gosh, now it was Arizona company. I even forget what that is, but they came out with the compact iPack. The product was called the Wave Runner back in around 2002, I think it was. And that was kind of the first handheld, you know, Wi-Fi tester. And from there on, you know, not long after that, we started working with UC at a former employment of his, and then came out with, or then acquired the Air Magnet company about 2008. And then the AirCheck came out, I think it was in 2012 was when the G1 AirCheck came out from then Fluke Networks, now under NetAlly. So yeah, it's been an interesting ride the whole way along. And spectrum analysis has always been kind of a key part of that. You know, back in the real old days, we were actually reselling the Cognio product that subsequently got bought up by Cisco. And then the Spectrum XT product as part of Air Magnet. And you know, we know that Spectrum has always been a concern of people to be able to see what's happening in the networks that is not Wi-Fi energy, and the ability to understand where is it happening, what's generating that traffic, and can I locate where that generator is.
Absolutely. And yeah, people don't know this, just to re-emphasize. we used to work with Dan when I was with my previous employers, which was Ekahau, starting dating back to 2004. And you guys,
Yep.
so Fluke, where you used to work, OEM'd Ekahau's, site survey tool and branded it as the Interpret Air WLAN
right.
survey tool.
Just Interpret Air, and then the Cognio product we rebranded called Analyze Air.
Exactly.
And then, of course, subsequently with acquiring Air Magnet, it's like, okay, well, company kind of moved on.
Yeah, you ditched me.
We ditched you.
Prettier Air Magnet.
We just threw you out like a something.
I might have been slightly upset at the time, but the time heals all wounds, and here we are, man.
Good old friends.
Exactly right. Exactly right. Either way, Keith, what about you? Like, what's your typical toolkit? And you've talked about this kind of like, different grades of tools and different cost levels of tools and stuff like that. Can you talk through a little bit on how you see wireless analysis? And you've also been in the game for a couple of years. So where do you come from?
A couple of years, yes. Usually that's in decades, not years. That's thus the
That
white
makes
hair.
two of us, my friend.
Well, I still have the white hair. You might have white hair if we could
Ouch!
saw it.
First Dan ditches me back in 05, 06, and now you.
I have seen pictures of you with hair though, so it's there.
It used to.
Yeah, I kind of love tools and I think they're great. There's like the first tier is just using the laptop you have with you and you can collect a ton of data. One of the reasons I like Macs is because the Mac OS allows you to talk to the Wi-Fi natively and get it to do all sorts of fun things. So that's kind of the minimum level. But there's times when even with the most sophisticated packet captures that you can see, there's something that's in the RF that you just, you see echoes of in the packets, but you can't really find. And at those times, you need a spectrum analyzer to get that actual thing you're looking for.
Absolutely. And the best tool is always the one you have at hand. And like, for example, that's why I love the NetAlly kind of handheld tools, because it's like for the IT admin, it's kind of often the go-to thing, and that's always there, and it's preloaded with the software. So it's a handy concept.
And I like them because you can send them to people, and the interface is easy enough. You can just say, "Go do this thing." And it comes back and you can get the data.
I would agree with that. I would agree with that. Kjetil, do you have anything like do you have access to like just a Wi-Fi NIC based analysis? And can you show something like what the Wi-Fi NIC can detect from your end? Obviously it can detect Wi-Fi, but do you have anything? What do we got for test gear?
Everything. What do you want to see? It can be whatever. So I have everything connected.
Should we start with what do we see from a Wi-Fi NIC, and then we should gradually start moving to actual spectrum analyzer.
Yeah, let me do that.
Well, let's start with the Wi-Fi NIC, like what it can.
I'm using AirPlay to my desktop, my Windows PC. So let's see if that has worked every other time.
Man. We need to talk. We need to talk about your OS of choice.
It works. There, and let me do this. Does that look okay?
This is an iPhone on a Windows.
Yes.
Something like that.
This is an iPhone on Windows, right? And and a pretty high signal strength for Unit 3 in Norway. Okay, hint, USAP. Remove that word in there.
We never heard anything.
Nevertheless, it's placed closely. So the cool thing, right, is 0 clients, nothing is connected, right? And without connecting any type of spectrum analyzer. So I always wondered, are there anything that we can see? Let's see if I can get this up and running. Then you don't see me doing anything here yet.
Not yet, no.
Yeah, I mean that's on purpose. But I'm just talk in the background while I'm doing this, pressing the buttons. Let's see it there. So
I think we'd rather just sit and awkwardly watch you.
While I'm thinking out loud.
I think well, you are you ready?
Yeah, if you do this,
so
I'm gonna
This is Hamina
Yeah, just talk.
on-site, right? And somebody was asking which app is this.
Yeah, this is Hamina on site. And what I'm gonna do, I'm gonna create. Oh, what happened there? 0 clients, and it's completely red. And again.
So you on in the Hamina on-site, you only have the Wi-Fi adapter connected.
Yes, only the Wi-Fi adapter
no
now.
spectrum analyzer yet.
No, nothing connected
Just
now.
see
No.
some kind of utilization on the channel. So what do you have?
Right now, I have an Aruba 735 on the floor and have a directional antenna that is sending a small carrier wave, a small signal, to trigger energy detect. And usually, when it reaches a point where you only get like 1 beacon every minute almost because everything is broken because the signal is too strong, you see channelization raising. And the other interesting part, before you see, you'll see this happening before it triggers energy detect or anything less. If the application support noise, please add it, because since in Wi-Fi they look at the entire channel, they cover like the thermal noise for the entire channel. So if you bring in a 1 kilohertz, like a really tiny signal, it will base the new noise floor on the strength of that signal. So if it's 1 kilohertz wide, a small carrier wave, so then you can see the signal. I use this if I have this in the dashboard, in the Aruba or Cisco dashboard or Meraki or something. You see the noise level go up to -70, -60, and then it just kills. And then you can control the noise
that's
level.
also just from a Wi-Fi adapter.
Yeah,
so Wi-Fi adapter can kind of a little bit detect this, and thus also the radio resource management systems that control the channels of the APs can work around a little bit, work around these APs, right?
Yeah,
so
usually if you measure, you walk in a survey and you measure like this noise level is measured to like -70 at a place. That would usually never happen if it wasn't any type of interference signal that raised the noise floor that high up.
Yeah,
because
exactly.
Noise level will be based on everything that it can't demodulate, and a proper enterprise access point can demodulate really low. So Keith and everyone else can probably say if I'm wrong here, but Jerry, you have a question?
Well, let me just make sure, just to clarify for the audience, because I've got this all figured out. But let me let me see if I'm understanding correctly what we're showing here. So you're using Hamina on-site, the mobile application on your iPhone. You've got something connected to your iPhone that's actually reading this information, right? What are you using for that? The Nomad.
Yeah,
okay.
The
So
Nomad.
you've got the Nomad connected to your iPhone. To Hamina on-site, and then the Nomad is hearing this information that you're displaying here that's being transmitted by the Aruba access point, and then the utilization that it's reporting from the access point is coming from an energy source that you're basically aiming at the Aruba AP to trigger that utilization on the channel.
Yeah, so it will be from the QBSS element. It will be in, I never seen the number 100, but I've seen 99. That's the highest number I've seen in a beacon. But then it's just when they have so much signal that is disrupting it because of the energy detect. Any signal above, let's say the explanation for the audience here, if it is a signal that your radio doesn't understand, and it hears its signal at a value at, I think it was 62 dBm, for example, and it will trigger it. And you can even configure a single source interfere 1 dB below that limit because it's hard coded from the vendor. So if you get 1 dB up, the Wi-Fi completely stops. And then I can just do it. And you can see this clearly because the channelization will go up before it
Isn't energy detect even in the 802.11 standard, right? The level of energy detect, Mr. Mackenzie.
It is. It's in the standard, and it's -62 normally for. So any signal above -62 will get detected as the medium busy. I think something that's interesting here as well is that obviously you're looking at a 40 megahertz wide channel there. So when the AP detects energy, somewhere in that 40 megahertz, it shows the whole channel as utilize, if that was an 80 meg channel, we would see 80 megahertz of red. Even if actually there's only one tiny part of that channel that's got interference on it. So it might be that you actually could go to a 20 meg channel on channel 161 and you'd have fine, and there wouldn't be any utilization. But actually the interference is on channel 157. And I think that's where you start to get the limitation of just looking at QBSS.
Exactly,
Yeah.
exactly. And then
Because it's too strong that the SSI, the beacon will just disappear. You'll not see anything else. It'll just stop.
Absolutely. You can, if you trigger it too much, you can send beacons and then you get nothing. Yes, that's the other thing you've got to remember.
Let me see if I can share this. So thus enter like something more beefy. So what I did is I connected to my Nomad this small magical dongle that maybe Julio or Dan can show, but it's essentially the NXT 2000. It's a magical, almost like a magical device. It's so small, but it's so powerful in terms of spectrum analysis. And granted, this probably isn't conveyed to you guys as quickly as it is on my screen, but it's extremely fast how it goes. And this kind of starts.
Was
to
it quicker
give
on my
us
Windows
more.
PC? That's hilarious. Go Windows.
You see, we're pretty close to real time. Actually, it's like there's a hiccup every now and then, but it's dang close to the actual frame rate. I'm surprised.
Even though I'm doing AirPlay from my phone to my laptop and then wirelessly over, well, it's a pretty well configured network, Joel, I guess here.
Thank you very
you can
much.
see, for example, it's, for example, Bluetooth next to channel 14. You can see those spikes. That's Bluetooth low energy. There was some probing. It swept through the channels. And here's Joel. This is probably your lab testing. We're seeing consistent throughput on channel 1. Would this be your throughput occasional throughput test?
Yep, it's one of those. There's 3 Raspberry Pis over on the shelf. Those poor things, they just sit there and hit an iPerf server all day long. Those poor things. I feel bad for them.
Oh, that's too bad. But 5 gig, obviously a lot cleaner. Thank you for leaving us some airspace to host this webinar, for example. Much appreciated. But it's like so incredibly fast, this whole thing, and it supports 6 gigahertz as well. So Dan or Julio, what's the story behind the NXT? When did you start looking at it, and how did it come to life?
Yeah, so a few years ago, well, let's go back a little further on the AirCheck G2. So on the AirCheck G2, one of the options that used to be available is that besides being able to see utilization, both Wi-Fi and non-Wi-Fi, similar to what you showed earlier using the Wi-Fi radio, that Wi-Fi chipset that was available on the G2 also had the ability of identifying non-Wi-Fi interferes. It wasn't a spectrum analyzer, but it could tell you if there was a microwave oven or a Bluetooth and so on. Still, when we moved to the G3, we moved to a different Wi-Fi radio. Wi-Fi radio on the G2 was a Wi-Fi 5. We moved to a 6E radio. And even though the G3 still can see both Wi-Fi and non-Wi-Fi utilization, not only using QBSS information, but also by measuring the energy on the channels, it did not have the ability of looking at or identifying non-Wi-Fi interferes by itself as part of the chipset itself. So we had to basically had lots of requests for bringing back the functionality to get visibility into the spectrum and non-Wi-Fi interferes. So we did some research, and the best way was to basically introduce a new spectrum analysis solution. So at the time, the quickest, easiest way, our first version, was by OEMing a solution. We called it the NXT 1000. the NXT 1000, and I guess this is common knowledge, so I don't think Dan will blame me for mentioning it here later.
ahead.
But it was an OEM from your friends from Osium at the time, and it worked, but it was only dual band, and
That's
it
right.
had
Gigahertz was around the corner.
Yep. And the air check was tri-band, so there was like a mismatch there. Hey, I can see all the access points on the 6 gig with air check, utilization, and so on, but I don't have spectrum visibility.
Yeah.
So we started looking at a tri-band version of, or a tri-band solution for spectrum analysis. At the time, there wasn't a lot out there that would basically match or agree with our standards. We wanted something with a higher resolution, a faster scan times that was available on the market. So instead of going the OEM route like we did with NXT 1000, we decided to design our own solution. So this is completely built in-house by the NetAlly R&D team, and kudos to them if they're watching. Hey, hello. But basically, we decided to go this route. We took feedback from what we heard from customers. For example, the NXT 1000 only had the option of an omnidirectional antenna, which was a little external antenna that you screwed into the top of the adapter. But people wanted also the option of locating interferers. So they asked for an option for an external directional antenna. It will be optional. So we decided to put the omnidirectional antennas internally, and then have a little port to plug in an external directional antenna that you could use to basically just locate devices a lot more easily than just basically walking around. There you go. Thank you, Jerry, for showing it there. Than just walking around. We also increased the scan time. So when compared to the NXT 1000, it goes a lot faster when scanning the 2.4, 5. Well, I show that example there. And we also increased the resolution. Because one of the things that we heard is that, well, the resolution scan time on the NXT 1000 sure it gives you some basic visibility, but may not be enough detail to, for example, fully identify what I'm looking at, what type of interferer it is, or how often does it show, etc. So yeah, it took a while. Reality is this internal information, but I hope no one minds if I share. But if we had to
There's
delay,
nobody listening, so you're
yeah,
okay.
we
Less
had
than
to,
5,000 people, so that's
but yeah,
normal.
we had to delete, basically push out the release or delay it like 2 or 3 times. We were hoping to release this like a year before we actually ended up releasing it, but let's say we were trying to be very careful and let's say very picky about the details. We wanted to make sure it actually worked with no little hiccups or problems. So yeah, the R&D team spent all the time on it, and personally, and based on the feedback we've received, I think it ended up being great. So,
Dude, absolutely, and we've had some conversations with Julio, like a lot of them recently with our customers. Just now that guy also plugs into the Osium Nomad survey device. Like there's so much interest in just because just plugs and it works. It's you could say it's generated some demand. And now I don't know if you've seen this, guys, but here's the kind of the latest thing is NXT on a survey, NXT data saved on a survey route, and then being able to analyze that on the Survey Explorer as well. And because of the high granularity of the data, it's quite amazing. Like the amount of detail you can analyze post-survey as well. Of course, like the networks, the APs, and without an NXT, you'll get kind of the bars and utilization stuff like that. But this thing like really also like for the CWNA, CWNE level people, it really blows the analysis out the water as well. And do you have a, can you show this? It's also there on the G3. Is there a way for you guys to share the G3 with the spec and all of that?
I sure can. One little moment.
What I liked about that, you see that you are not compressing it as much as others. So you get that more prettier spectrum view when you walk around.
Yeah, it's very granular. It's very granular.
That's the
there's a
beauty
lot
of cloud and not having a local file format.
Yeah,
Right. You can just fill it up.
100%.
Cool.
I think Anders makes a really good point in chat too about like the NXT 2000 working not just with the air check. So you invest in this spectrum analyzer and now you can use it on a handheld platform like the air check. You can use it with the Nomad, and I can just unplug it from the air check. I can plug it into the Nomad, and now I've got spectrum analysis with Hamina on site. You can take it right from the Nomad and I can plug it directly into my MacBook, and now I can get spectrum analysis on my MacBook with Wi-Fi Explorer. I mean, like, I don't know, I'm probably, a bit biased, being part of that kind of ecosystem, but what other tools, in this space give you that kind of like value for that investment? I think it's pretty cool.
Yeah, and that's one of the things we wanted to do. We didn't want to limit it to only being able to use it with, for example, an air check in this case. We wanted to also make it available for other methods or through other methods. For example, one of the things we had lots of requests for when we release it is that, hey, or one of the biggest questions, hey, can I just plug it into my PC, laptop, or tablet and use it directly? And within, besides the Android app that we use on the AirCheck, Etherscope, Cyroscope, and so on, we didn't have an option. So yeah, we decided, hey, let's make it available for use with other tools like Hamina on site or Wi-Fi Explorer Pro and others that you may see in the future. And hey, let's make it available to everyone. After all, it is a very unique solution. And yeah, there's other USB-based spectrum analyzers out there at a similar price range. But when you consider the power of the NXT 2000, the resolution, the scan time when compared to those, well, it covers a space for where there was no other solution out there.
That's
unless you wanted something with less power or something a lot more expensive or on the higher end of things.
Yep. And this wasn't our first integration rodeo, was it? I mean,
Nope. Basically, we started, and this maybe more than a year ago now, with the Air Mapper integration, where you have the option of just using an air check, for example, doing a site survey with the Air Mapper app, uploading that information to Link Live, which is what I'm showing here on the screen, and then basically just importing that into the Hamina Planner Pro. And from there, you can use it or to compare these site survey results against the design, or you can even use that to basically calculate the attenuation on the walls and have the Hamina Planner draw the walls and all the information in there automatically. That was pretty impressive when I saw that. It's like, ooh, that's pretty cool. So, but yeah, what we're seeing here, you see, is basically the NXT 2000, in this case, on an air check. I'm sharing this how it looks like through Link Live, which is our remote control. One of the things that was mentioned earlier is that you have the option of basically just sending an air check or any of our tools to someone on the field, and they don't have to know what they're looking at. You just need to tell them, yeah, just go stand there, plug in that USB adapter on the top of the unit, turn it on, and then you can just take remote control of the unit and do your analysis. And in this case, we're looking at the Spectrum app. You have the option of looking at all the different bands from here, I don't have at least on my neighborhood. There's not a lot of traffic on this 6 gig besides my own.
like most neighborhoods.
Yeah.
That would be, I guess. So
Yeah. So that's
and you have
good.
different
Good because
visualization modes.
I can crank it up and use wider channels because there's no one else I'll be interfering with on the 6 gig.
Exactly right. Exactly right.
But you have all the visibility, all the basic visibility in here, option to using the external antenna and so on. And one of the other things that we added when compared to the previous version is that we're using a real-time FFT or fast Fourier transform on the NXT 2000, and that's where we hope in the future to bring back that functionality, which triggered the creation of the spectrum analyzers for us, the automated interference detection in the future. So that's basically why we brought back the spectrum analyzers, basically to make it as simple as possible to identify or locate interference.
Absolutely, and I'll steal your screen, if you don't mind, and let's move to like looking at a couple of common interferers, if that's okay. Like how do they look like, and where do they live? If we, I hope you can see my iPhone screen. So,
We got it.
scrolling down. On 5 gigahertz, I did set up Joel's motion detector. Maybe you can see my camera, but there's a it's called microwave sensor, but it's really a motion detector, which I have stolen from Joel's desk, and I hope I don't misuse it and catch fire. But anybody see where that lives? It's that small spike guy right there, right above channel 153. And this is what I love about the tool is like it very, very accurately picks up even the narrowest of band interferers, right? So, and what's kind of funny about these motion detectors is I'm just waving my hand over the motion detector and see how the frequency starts to dance for me. So that's kind
You're like
of
a
cool.
snake charmer, you see. Make that spectrum dance.
Exactly, and with that terrible snake charming, song over to somebody else. Anybody else have some real life interferers besides just this guy?
For some reason, I feel like maybe Kjetil does. Just a guess.
Yeah,
just
I can put it in the chamber and see what we can do, and but then I need to disconnect and connect back. But first this little thing that I wanted to show, so really quick. Let's see if you can see it. The signal that I showed you last time, that was a signal. That's how really, really, really tiny that signal was that trigger energy detects. And
wow!
again,
So that detect
now stop.
that
SSID is
triggered.
gone. Yeah, so it's gone.
Wow.
So it's back. But that is like that Julio said that using FFT or using an ADC, a single ADC 12-bit 80 MSPS megasamples per second for all those nerdy people out there.
I understood exactly 0%.
Yeah, but instead of having a typical voltmeter that you're tuning and measuring one little bin at a time, and coloring like one little slice every time, you just take 1024 or 2K or 2048 points and paint it, and then you paint back. So you're like a super fast Bob Ross that's sweeping the band.
Wow.
Then you can see more, but then I can disconnect this and put it in the chamber. So if anyone can just chat along in the meantime while I do that.
Anybody have a quick interfer display in the meantime or something? What do you guys see the most? I'm starting to see like obviously microwave ovens and stuff like that, but on 5 these motion detectors of lights to me like motion detector enabled lights are maybe one of the bigger ones. Jer Bear.
So here's, I think, an interesting kind of real talk moment of the webinar is
real talk. It's about time.
Real talk. No,
minutes.
none of this marketing BS anymore. Let's have some real talk here.
Yeah, exactly right. Go for it,
No,
Jerry.
I think this is really
you,
interesting. And I think the timely piece of this from the beginning of the webinar, for anybody that missed it, we were talking about 6 gigahertz and how yeah, we're not seeing expansion of 6 gigahertz to the full 1200 megahertz in certain parts of the world. And we're also seeing stuff about the kind of the opposite of that, right? Of being able to, certain parts of the world actually retracting on that and going to only 500 megahertz. The reason why I'm bringing all that up in this real talk segment here is because I've actually been in the mindset of spectrum analysis is actually becoming less valuable in the sense that we've got so much spectrum available to us, at least in the parts of the world that we have 1200 megahertz of spectrum. It's like, if you've got a narrow interferer like Kjetil was just showing there, do I really care about it if there's, a couple of those in this 1200 megahertz of spectrum, because we can just move the APs around and APs will just avoid it on their own. So I don't really need to go hunt down these interferers. But if we're only down to 500 megahertz on 6 gigahertz, does that kind of change the perspective? And yeah, I mean, it puts things into a different perspective for me, at least, of like, okay, the spectrum is a little more precious than maybe what I, have been thinking about, and at least in regards to 6 gigahertz. 2.4, yeah, you're going to see the Wild West there. We're going to see all sorts of stuff that we really don't have a whole lot of control over. So it's just best to avoid it. But 5 gigahertz, 6 gigahertz, that's still pretty precious to us as wireless engineers and network administrators, that we need to, still need the tools to be able to visualize that kind of stuff and see what's out there.
Yeah, I would add to what you said as well, because I've had this argument, is that do we really need a spectrum analyzer, because nowadays RRM is just going to move to another channel and it'll move around the interference, so you don't need to know where it is. And I think where that potentially is a downfall, especially if we've got less spectrum, we've only got 500 megahertz, is you may have done your design and gone, as Keith likes to say, use the widest channels until you can't. So from a theory point of view, you're like, oh, I can use 40 meg channels, or I can even maybe use 80s if you have lots of spectrum in the US. But actually, if you start to get interference coming up, that takes out some of those channels. All RRM is going to do is not reduce your channels, it's just going to move. And then you'll start getting co-channel interference as it's avoiding the interference. So being able to detect where these narrowband interferers are and actually know which channels are affected allows you to make a better design decision. You might actually go, well, actually, we've got to go to smaller channels to avoid a co-channel. And I think a lot of people miss that point when they say we don't need spectrum analysis.
Agreed. And especially in these interface for heavy environments, like stadiums and factories, it's definitely very, 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 very useful. But I gotta hand it over at the same time, keeping it since this is real talk segment. Which is sponsored by Jerry's conference bands on the right hand side of your screen. Sponsored by your badges. So I gotta say the RRMs have gotten extremely good as well recently. Like they've gotten very, very, very good at the same time. So at least to me, like there's something's happened in the last 5 years. Some of that was probably 6 gigahertz came along and freed up more frequency, but also I think AI has helped a lot. But somehow RRM just works a world better than it did before. Kind of like maybe neutralizing some of the need for high-end analysis at times. But yeah, over to Kjetil.
And a small mention about that. I did to check how RRM works, right? So I used an Aruba access point and I created a radar signal and I stepped that for every single DFS channel, right? And then I disabled every channel, absolutely everything, in less than 10 seconds or 5 seconds, right? But then it just ended up in Uni 1 or Uni 3. So then you have at least if you walk around being an asshole and doing that at an enterprise, right? You will have every access point in the entire campus on 4 channels. It works great. But on Uni 1 and Uni 3, there you can generate a lot of different signals. Then it won't, because it doesn't look for a radar. So there you can generate a lot of things, but it usually, still, depending on RRM technology, move away.
Yeah,
right?
exactly.
So I had some
TFS is
Meraki access point,
mandated.
and I did a microwave video once, and my Meraki access point always changed channels when I turned on the microwave, and I got so disturbed that I had to use another access point that RRM worked worse on, because it always changed to channel 1 because it was interference 6 and 11.
And it's not just varied at, because I've actually, when troubleshooting, been in organizations where every single access point was on Uni 1. And they weren't configured like that originally, but over time, they'd all moved to you, and then they're never going to move again because they're on non-DFS channels. So that does still happen with some vendors' products, and with others they'll try and move back. So it does depend on the algorithms. But you are right, UC, they've got a lot better, and they're generally pretty good now. Algorithms.
What are you seeing, Keith, in the out there in the wild in terms of RRM behavior, and like, would you concur with this?
I'm not a big fan, never been a big fan of RRM, but it's one of those things that is you just have to live with. When you have 2,000 APs, you're not going to be touching them manually. But I've seen different vendors over 15 years now trying to get better and better. I like when the RM algorithm includes the client side. So they make a change. They look at the clients. Are the clients happier? Better MCS rates, lower retries? Well, that was a good thing. If it wasn't, then put it back. So RM is getting more intelligent now. And yes, every one of my customers uses RM at some level. It's how much you rely on it. I've seen some do some really stupid things, though. But then again, I get paid for fixing them, so
nothing wrong with that. But I agree with the client behavior, like observing the client base and its health, and combining that with reinforcement learning. So make RRM tries different changes, and then reinforcement learning algorithms just like figure out, was it a good change for the health of all the clients or not? That's really amazing. But back to Kjetil.
Ketil's just showing off now.
Yeah, man.
I'm just been playing in the background.
So what do you got? You have an Aronia as a signal generator.
Yeah, I have an RF chamber, a huge, thick cable to prevent some leakage, and a couple of antennas and an NXT inside the chamber, and I'm just generating some signals to just test.
That just goes to say how quick the NXT really is and how accurate it is.
Yeah, as I'm moving with my hands, and I said left, stop, right? So that's how I made that. That's how I made that video, right? I did this. So now the Thomas the Tank Engine. Just sat and listened to the Thomas the Tank Engine on Spotify and doing this and just making. Yeah, but it's there's all type of like really high. I have Aronia and have like all the way to laboratory equipment, right? With like desktop for several 100,000. But I use it for testing other analyzers.
Even though you have that high utilization on channel, like in the middle of channel 11, the AP on channel 11, the beacons are still there.
Yeah, remember that now Nomad is not in the chamber.
NEC62.
Yeah.
Right?
The best thing you can get for yourself is a really good old USB 2 cable. If you need to connect to your chamber, get like a proper thick, it's a 5 meter long USB 2 cable, because that doesn't interfere. I used a USB 3 cable, and the whole chamber got so much noise, so I had to use. So like
what if you? Yeah, Knight Rider indeed. What if you raise the? Can you increase the amplitude of that? Like get it to above NEC62 or something like that?
Yeah, I can do that, but then we usually get a lot of phase noise, right? Because it's so strong. So that's the phase noise of things.
No problem there. But let's see if you can make the beacons disappear from channel 11, for example.
Yeah, remember, it's the signal is being generated inside a chamber that has 90 dB of.
Yeah. So it's not visible to
that will not escape at all. It's a mobile phone testing chamber. So
I will not call you Kjetil. I will call you Kjetil for cheating on this.
Yeah, but I have tried. If I open it up, right? So here's a magnet cover.
Now, if we had visibility to Keith's keyboard, it would be tapping to Aronia's website, going to buy one of these devices. I can see it in his eyes.
Yeah. But
it's fun to test. Like
I
it
did
fits
want to.
the.
Oh,
Sorry,
Keith.
Keith.
No, I did want to confirm what Jussi was saying. A lot of times when you play with interferers, you can see how much it takes before the beacon stops transmitting. And so even without a spectrum analyzer, if you use and you practice with these, you can pretty soon just watch the beacon, the little ziggurats, whatever Joel calls them, the little boxes. And when they go away, that means we don't see a beacon, which means you trip that threshold in the Wi-Fi algorithm. So getting used to that is a very useful way when you don't have a spec an to see how bad something's getting. And or the flip side is the beacons are still transmitting on top of stuff. Your Wi-Fi is still playing nice.
Yep. This is
The only
just
issue is like you're gonna kill Bluetooth. Then you need to block every channel. So you need 80 megahertz of noise, right, to block Bluetooth. But you need 1 kilohertz to kill Wi-Fi. So that's how stupid sensitive Wi-Fi is.
So, Jerbear, you have a raised hand.
Yeah, I was just curious actually to chat. I know we're already kind of over a few minutes here, but we'll probably keep geeking out
Dan,
here
you are
for a little
excused,
while.
by the way. Daniel Klimke has to go see his boss. So I just want to make sure you don't get fired. Say hi to your
But
boss.
Daniel, if I break it, will you send me a new one?
Of course.
Hey, Dan, how can people get easiest access today before they can buy this through Hamina? How do people get easiest access to the NXT 2000 spectrum analyzers? For example, if you're a Hamina Nomad customer, you want the NXT as well. What's the easiest way? Daniel.klimke@netally.com, right?
Yeah, that works. Or go to netally.com, and we'll glad to help people out, find a source for it. Our products are sold through typical reseller channels around the world. So I'm happy to get more of those out in people's hands and get them working for you, just like, maybe not just like Kjetil's using, but would be glad to get them out there for you.
Thank you so much, Dan, for joining, and thank you for the partnership. It's been great working with you. Even
Indeed.
though I have a little bit of a black eye from 2006 when you acquired Air Magnets.
Hasn't that healed just yet? Come on.
No, still a little bit. Oh, that's just a wrinkle. Thank you for joining, man. Say hi to
All
your
right,
boss.
hey, gotta run. Thanks, guys.
See you, Dan.
I did want to turn it over to chat though of, Kjetil showing this in like a chamber and using signal generators, stuff like that. That's not stuff you're typically going to find obviously in the real world. So I'm curious with chat, those of you that have done spectrum analysis, what are some of the interfering sources that you've located using something like a spectrum analyzer to track those down? Particularly, I'm interested also like outside of 2.4, right? So list what band you've actually seen those interfering sources in. Was it in 2.4, 5, or even potentially 6 gigahertz?
Vernay says lights in Unit 3.
Yeah.
The lights themselves, not like a motion sensor on the light?
I would think a motion detector, right?
And that's also similar to the signal that I generate in Unit 3. It's the same thing, right? That's why Unit 3 is like useless, because if you have Vernay's lights, you can't use those channels at all.
You see them a lot in warehousing or staircases, places where they want the lights to automatically come on when people walk in to an area. And they tend to always be in Unit 3, in my experience. Yeah.
So then we finally got more non-DFS channels in Norway, so we can't use them in warehouses either way, like because of that.
What about you, Peter and Keith? What are you seeing in terms of like the most common besides a motion detector?
Well, I don't think that they're ever most common, because when you see these and you need this spec and to find them, it's because they're not common, and then you have to track them down. And it's a whole different technique for finding RF interferers than it would be an AP. For an AP, you have a MAC address and you can lock on it and play and get really close fast. For RF interferers, you have to do a different technique. What I use is a grid. You cut the room into 4 chunks. You go to the 4 chunks and measure what that RF is there. And then you cut the highest one into 4 more, and you work your way down to find it, especially when they're not constantly on. It sometimes takes hours and hours to track something down physically, because you don't know what's triggering it. So you have to kind of wait in each of those quadrants. And then you go to the smaller quadrant and do it again. So it's just a different technique. NetAlly does have a directional antenna that you can use. I found that's actually harder for people to use than the warmer, colder technique. Because even though it does have a pretty decent front to back ratio, if you're really close, the back side is going to still come in and you'll be facing the wrong way, tracking it down.
Yeah.
I think it's
And
got
also
close, but once you get close, you may as well just go on hot, where it's hotter.
Exactly.
I agree.
And also without the external antenna, the NetAlly NXT is more sensitive on the back side, at least for my measurements. So if you just turn it around, you get almost 5, 6, 8, 9, 10 dB more sensitive. So you can almost use that as your as a direct antenna.
So which side of that are you talking about, Shuttle? The side with the
with the back,
ribs?
with the back, with the not with ribs, the other side. Same thing we do with the Sidekick 2, right? It's really sensitive on the back. So usually if you're going to do some measurement, you turn it around and you use the, sorry for mentioning echo, everybody, you turn it around and you use it on that side because it's more sensitive. Because
you already say the A word as well, so why not?
You have said the E word already before me. So, but yeah, everything has, nothing is perfect Omni, and it's always more equipment on one side than the is on the other side. So you will get more that. So yes, I would not, if I was sending this, I would not send the additional antenna because it would be more confusing and more things that can break. So I would.
Yeah, a fun little thing I found once, just when you talk about location, was it was in the 2.4 gig band, but it looked almost like wideband jammer, and it was in a retailer, and everywhere I walked, the signal strength never dropped. So trying to locate it was just impossible. It was everywhere. And what I realized, it did look like Bluetooth, but like lots of it. And it was at like neg 20 dBm across the entire store.
That's hard.
And when I eventually figured it out by just looking around, on the top of every light, there was like strip lights all the way down every aisle in the store. At the end of each end, there was a little grey box with 2 antennas on it, on every single light. So across the entire store, there was hundreds of these little boxes, and it was a Bluetooth lighting system.
Yeah, it was
and the combination of all of these boxes all transmitting at the same time, while they were all low power, the power spectral density was up at neg 20 across the entire store.
It was a smart light that was smart enough to kill everything else.
Everything else, yeah.
But it doesn't kill other Bluetooth. I've been in sites where they had hundreds of Bluetooth mice and Bluetooth keyboards, and they all worked fine. Just Wi-Fi didn't work. So Bluetooth's really resilient.
It's incredibly resilient. So Bluetooth worked fine. It was just Wi-Fi that it was killing. Sometimes it can be challenging to locate. It was just with Keith saying that sometimes you find it really difficult, and in my case it was everywhere, and that was why I couldn't locate it. But another common interferer that I'm seeing a lot now, if you ever work in venues that have production companies come in, so maybe it's a stadium and they've got a concert and they're going to be filming it, the cameras now, instead of trailing a big cable around with them, sometimes they do that. They actually have radio packs on the back of the cameras, and they tend to operate in 5 gigahertz, the ones I've seen. So if you're at a large event, or a concert was when I first saw it, and there's maybe 10 cameras, they literally take up the entire 5 gigahertz band because everyone's on a different channel, or they're using quite, and it's absolute. It kills Wi-Fi. And
uncompressed high-resolution cameras are extremely spectrum hungry, aren't they?
Incredibly. So what we ended up having to do was work with the production company to literally split the band, and they had a chunk of channels and we had a chunk of channels for the Wi-Fi, because there was otherwise no other way of doing it.
It is, though, it's something we have to live with because it is unlicensed bands, and so they have every right to be there the same as us. So we just have to play nice.
Yeah. But the boring part, I saw one of the worst interference that I found was in a parking garage. I never found out what it was because I had to run to get the train. But it was 40 megahertz up to neg 30 in the middle of the parking house, so it was probably really, really strong. If I got anywhere close, probably
Wow.
blow up my spectrum analyzer. But it was in the middle of channels. So it killed like 220 megahertz because it now 3 channels at the same time.
So don't parking garages have these sensors? Some of them have for each parking spot,
but not
that
30
detects...
megahertz. They don't need that much for a sensor. That's probably 200 kilohertz or something. But I never found out what it was. But that wasn't. And the cellar and the first, second, and third floor, it raised the noise floor all the way up to the third floor. So it was meeting rooms had like minus 82 like noise floor, minus 80 almost, like raised it. You can see it in the survey file.
Wow.
And that is the story of why I ended up wanting as an Aronia, because I had to record it, and everything I had was a screen record. So I wanted to decode what it was.
If this was the real talk segment, the real talk segment would say the reason you wanted Aronia is because we want more toys. But since this is not real talk, we will take your excuse for yeah, sure, there was a parking garage and all of that. But in the I bet like some of the systems that detect whether the parking space is available or not, because you have those X number of parking spots, like hundreds, and if you have one sensor per parking spot, and that led me to think. Just this morning, I was watching a video of the new Porsche Cayenne electric, which has wireless charging, supports wireless charging. So you drive over a charger in your garage and it wirelessly charges. I wonder if that goes all the way down to 5 or to 4 or stuff like that. It would be nice. Actually, that's a challenge for you, Kjetil, or Peter has also Aronia, right? So measure one of those wireless car chargers. Like, to me, like the amount of energy it has to send and the amount of like, width probably on different frequencies that it'll take. Let's see.
Yeah, it depends. I don't want to blow it up. But I'm going to a site to measure signals that it's been transmitting at 20 watts. So I had to use vibe coding to calculate how many attenuators do I need, how far should I stay, just to have like tools. Now I can input all the variables, and it says you need to add 30 dB of attenuator and 110 dB, and you need to stay at least 50 meters away, or else it will blow your analyzer.
Wow.
Well, that's one little note that is really cool to NetAlly. In their guide, if you read, for those who read guides, they have a little warning. When it overloads, you rarely see that from other type of analyzers. So they actually see so it's in the data sheet of every chipset, but they don't provide it usually. But it says if it happens, you are overloading, and you will see signals, harmonics, and intermodulation signals that is not real because you're overloading it. And it actually, thank you, because it's but you need to go in the guide and read page 58 or something to read it.
Yeah, for those that have an air check, for example, on Interscope, on the spectrum map, you'll see a little like exclamation sign pop up on the upper left of the screen. If you see that, yeah, that's the warning Kjetil is talking about. So.
Yeah, and usually you will see really weird things at the same time. So that just means if you start to measure, don't put it really close to, if you see a 5G panel, don't put your analyzer right next to it. So you'll probably ruin that one really quick.
Jerbear, any closing thoughts? We're only 18 minutes over.
Yeah, we'll give one last bonus real talk segment for those that have stuck around this long. Since I do have a lot of experience with doing site surveys and, as part of that spectrum analysis, my thought goes to actually, we're talking about all these, random interferers that you might find in the environment, but in reality, that's a very low percentage of time. If you're doing site surveys on a regular basis, you will very rarely find an interfere, right, in reality. But that said, I still think that's actually the most valuable part of doing spectrum analysis, in the sense that I can now check that box that I know if I'm troubleshooting a Wi-Fi issue, I know that the issue is not being caused by a video transmitter or Bluetooth or whatever that interferer, that we have in our minds might be. if we think this problem that this user is having might be caused by interference, I can quickly rule that out and move on to other troubleshooting tasks.
Absolutely, but like I said, you have to kind of be there at the time that it's transmitting, like Keith said as well, unless you have this, of course. If you have Hamina live, you can actually look at the network in real time and then start extracting things like not just like channel interference and all of that kind of stuff, but also channel utilization. And what's nice about this is it divides the channel utilization into non-Wi-Fi and Wi-Fi interference. So if we wanted to look just non-Wi-Fi on 2.4, which is disabled, so there is nothing. But if I had a better demo side, if I'd actually prepared even for a second for this webinar, I would have had a really nice, view where non-Wi-Fi would be present and stuff like that. But yeah, that's this is where I think like there's tools for every trade, right? There's tools for planning, site surveys, on-site troubleshooting, but also remote troubleshooting. And as Keith would say, I would assume, the more tools we have on our hands, the happier we are.
2.4 UC? Anything on 2.4?
I think
I enable it.
Yeah, let me check.
Did you record on 2.4? Maybe not.
Yeah, because
no,
2.4 is disabled in the whole
yeah, sorry.
whole thing.
Here you go,
Oh.
UC. I got one. I can show. I'll show the. Actually, here, just switch. Do you have a Meraki one?
Go, man.
Okay. Showing here, except for just a different network that does have some 2.4 radios enabled. So we are seeing some utilization on 2.4 under channel utilization. But what UC was alluding to is that we can filter that down from there and say, hey, is that utilization on 2.4 that I'm seeing here? Is that coming from Wi-Fi or non-Wi-Fi? So if I uncheck the non-Wi-Fi, we can see here, yeah, this is picking up the utilization on those channels is coming from Wi-Fi versus if I flip this to non-Wi-Fi, you can see the utilization is much lower. So it is showing that most of that utilization that it is picking up on 2.4 is actually coming from Wi-Fi. But yeah, if we did see the inverse and I uncheck the Wi-Fi and say, okay, is that utilization, that energy that it's detecting, they're coming from non-Wi-Fi sources, that's a great, use case to say, hey, we need to get somebody on site with a spectrum analyzer and investigate this more closely, track down where that utilization is coming from.
Yeah, and I can tell you where it's coming from. It's those 3 Raspberry Pis that are in the back. And even though they're not specifically, it's them. It's funny, even though they're not specifically on the Meraki gear, it just happens to be on the same channel, and so it's picking those up as Wi-Fi channel utilization, which a little bit surprising to me, but a nice happy side effect, very convenient for demoing and stuff like that, and webinars apparently.
Let's see. So let's take another live network right now, and granted, it's evening here in Finland. This is like an ex-hospital campus, and on 5 gigahertz, channel utilization is light. But what about 2.4? Because often this is almost downtown Helsinki as well. Here we go. We're starting to see some activity on 2.4. And let's see how much of that is Wi-Fi versus non-Wi-Fi. So if we just take out Wi-Fi, and we can see that it's actually non-Wi-Fi that's causing these problems. And we kind of emphasize, like if there's a lot of non-Wi-Fi, we show them on brighter colors on purpose to kind of emphasize that, yeah, if you have 17% of non-Wi-Fi interference, that might become a bit of a pickle. So yeah. Anyhow,
this is also a good point, right? That every time we have these interfere demos, we always have to look at the band we never use anymore. Like it depends on the site, of course, but in an office environment, only Joel needs his 2.4, right, for his ESP32s or something.
Yeah, it's mostly there for the ESP32s and demo purposes. I think we do actually. You know, I think we do have our Joan calendars on all the meeting rooms. No, I think they have 5 gigahertz as well. So really, it's mostly just for demo purposes and Apple Watches, I suppose.
They need to make a microwave that leaks on 5, so we have some excitement. So
yeah, I want to buy a 5 gigahertz microwave oven. Why has no manufacturer made this? Where's Miele? Where's Siemens when we need them?
Yeah.
Yeah, it just won't cook your food, but it would work.
For interfering with things,
Yeah.
just not cooking the food.
Be a great demo.
Okay, we're 25 minutes over quota here. Just like my sales targets. Oh no!
I can share the video of my microwave, but it's in Aronia, but it's so beautiful to look at.
Go, man.
Yeah, you do this and just press play.
And you could play it back in the 5 gigahertz band, couldn't you?
Yeah, but it's so much. There's so much you need to transmit. This is dancing.
That's actually one of the telltale signs that you have a microwave is that it doesn't lock.
No, it just moves slowly when you depending on
it's
how
like
much
Northern
watt,
Lights, man.
How much watt I put into the microwave. It's a built-in brand new one, right? But this is being measured on the other side of the house, 1 floor down.
Wow.
So short story, when I worked in Wi-Fi, worked with an ISP, like before I really could learn Wi-Fi, like 15 years ago or something, I created a Wi-Fi course. And that I had a demo with my microwave to show what happened, right? So I saw the speed. I took a speed test. I got like 20 megabits, and I took the microwave. I had 2 seconds latency and 2 megabits when I had a microwave on. And we lived in a parking complex with 6 buildings. We lived in the middle. And I always did these demos. And then since I worked in customer service, and then I checked my neighbors if they had complained. And 3 of the neighbors had called for issues with everything was 2.4, and they had been sent a new ASUS router from the ISP because there was so much issues around Friday at 5, and that was my microwave that took down their whole Wi-Fi because it leaked so much that the houses next and under destroyed their Wi-Fi. So that was me, but I could see that it did that, and that got my fascination about microwaves and from that time.
Have you ever got a microwave, stopped the plate turning, and put chocolate buttons in it to measure the wavelength of 2.4 gigahertz? If you've not, you should do that. It's great fun. You can see which ones melt, and then you can measure the distance, and you get the wavelength of 2.4 gigahertz. It's a good fun.
You can also do a Jello. Just put a little, like a ½ inch of Jello in the bottom, and then watch a round little pan. It works pretty good.
Yeah,
that comes good, but don't put eggs in there. Just a side
and
note.
This has been the real cooking segment of the webinar.
Not just talk, but real cooking. Sponsored by Kjetil's microwave oven. That's leaking a lot. Anyhow, thank you everybody for joining. Final thoughts. What's your 1-sentence final thought, Kjetil?
Yeah, use a spectrum analyzer when you need it. Always bring one with you.
Joel Crane.
Yeah, I think somebody said earlier that sometimes looking at the spectrum gives you the assurance that it's not a spectrum problem. So I thought that was a nice piece of advice. I feel like I just pulled the rug out from under somebody by stealing that from them. Sorry about that.
Awesome. Peter Mackenzie.
Yeah, I think I've always been a fan of doing spectrum when I'm on site because just like Jerry said earlier and Joel said, you can, if there is interference, I want to at least know it's there while I'm on site. So always have a tool with you. And I think the NXT 2000 is ideal because it takes up no bag space. There's no reason to not have it in your bag. It literally weighs nothing. So keep it with you at all times.
Yeah.
That would be my go-to. You know, I had the tools like Kjetil, I had the, you know, a Vernier tablet, but that thing weighs a lot to carry around with you. That's not gonna be with me at all times. But yeah, so I would just think it's a valuable tool to have in your toolkit.
You're such
Agreed.
a casual user, Peter. So casual.
I know.
But backspace is definitely one of my favorite things as well. I always only travel with a single backpack, even if it's a 3-week trip. It's a single backpack, and backspace is definitely of the essence. Mr. Parsons, what would be your takeaway today?
Well, I think I'll highlight what Joel was said about Jerry. Having it and having the data collected with a SpecAn gives you the confidence that it's not a Spectrum issue. But if you don't have one with you, you'll run across times when you just really wish you did. And so it's just one of those things like Peter said, it's small. It fits in your backpack. It's got a new slot in my backpack just to hold this NXT. I use a little USB-C to USB-A adapter, so it can just go right in my laptop whenever I need it.
Nice. Jer to the bear, as they call our man from
As
Wisconsin.
they do. Very few people do, but certain people do. I think this is the equivalency of a cable tester for a wireless engineer, right? It allows us to see that layer 1 piece of it and see, you know, if there's a problem with the PHY layer, right? So I think, yeah, just like if you're doing any kind of wired type, you know, networking, you're going to want a cable tester in your bag, which I think even if you're doing wireless, you should as well. But this is kind of the equivalency of kind of your cable tester for Wi-Fi.
Jared, it's funny that you bring up the cable tester thing. Back in my MetaGeek days when I was talking about WiSpy DBX all the time, I equated the DBX to the Link Sprinter 300. I got a Link Sprinter 300 from one of the WLPC bags. Thank you very much for that, Keith. That's one of my all-time favorite tools. Is Julio still on here? I can't tell.
Yep.
Great tool.
I'm still here.
Oh man, what a great little tool. I have 2 of them now and I just love them to death. But yeah, to me, the spectrum analyzer is the equivalent to the Link Sprinter 300.
Yeah, Link Sprinter is so good. It's an amazing piece of kit and so small again. Bag space, man. Bag space takes so little bag space. There you go, Jerry. There you go.
It is funny how similar size they are, you know.
Yeah.
Just throw them in a bag, and now you got PHY testers for both sides.
Yeah,
Yeah.
funny
What
enough,
about Tektronix?
funny enough, I never compared them side by side, but now that I'm looking at them when Jerry showed them, it's like, oh yeah, they actually are about the same size. That's interesting.
And Jerry needs a green one now, Julio.
Yeah, man.
Yes, he does.
Yeah.
Yes, he
I have
does.
both as well. The fruit one and the
I
NetAlly.
still have
I-
a yellow Link Sprinter. That is still the colour of mine.
I kind of like having the
They're
2
great.
colors. But I have them labeled differently in Link Live, so I can tell like which one was used for a particular test. But now I want like a little case for my NXT 2000 and my Link Sprinter 300, so I can have like, this is my little layer 1 testing case. I might have to 3D print something. A little layer 1 case.
That's an interesting idea. Oh, that also reminds me. I think Fernay was also somewhere here on the chat. Fernay, you also need a green one because I noticed you still have a yellow one somewhere. But final thoughts, and I think everyone already mentioned this. You may be wondering what's the importance of having a spectrum analyzer if it's something you don't need all the time. Well, it's better to have it and don't need it than to actually find yourself needing it and don't have it, and then you'll be like, oh no, how can I do it? So yeah, and as the team mentioned here, it's small enough, so it's not like you're carrying a full suitcase sized spectrum analyzer around. You can put it in your pocket. You can include, if you, for example, have an air check on the same carrying case of the air check just in there, or in any backpack. And again, it's not limited anymore to just working with our NetAlly tools. So if you're using your laptop like Keith with, I suspect, Wi-Fi Explorer Pro, then yeah, it's just on the same backpack you're carrying your laptop on. So why not?
Absolutely. And it looks like Kjetil is ready to drive us home.
Yeah, I'm gonna bring you all home with my fancy new little car. I'm gonna change the wheels and everything.
Oh, hold on, I
Yay.
can pin you. There we go.
Yeah, you need to pin me. Let's do you hear me? Now you probably hear me. I don't know.
That's a very Wallace and Gromity version of you, Kjetil. Anyway, with that bombshell, thank you everybody for joining.
Bye.
Next time we'll only do slides, since this time we had 0 slides. Next time it's only going to be PowerPoint extravaganza for 90 minutes, 800 slides, and all about business and marketing or not. This has been Real Talk with Jeriola. Thank you, everybody.
Yeah.
Over and
Thanks,
out.
everybody.
Bye, everyone.
Bye.